Welcome to the Getting to Know LXI video series brought to you by the LXI Consortium. Today's video, Going Wireless with LXI, is presented by Neil Forcier, Application Engineer with Agilent Technologies.
My name is Neil Forcier. I'm Application Engineer with Agilent Technologies, and I'm talking to you from Loveland, Colorado. Okay, so let me get started. Now let's go into going wireless with LXI. Now this first slide goes over some of the advantages to controlling instruments wirelessly, and a lot of these are fairly obvious. The idea, though, is it talks about advantages for both long distance test and the test where you might be doing right at your bench. And the idea is you can set up distributed tests maybe in the office if you're working on a satellite or aircraft and you want to have instruments around that aircraft. If they're wireless for connection, they're so much easier to move around and quickly set up a test, operate that test, and then reconfigure it. If we want to measure vibration on a high-speed rail line every couple of miles, we're not going to have Ethernet connections available. How are we going to set up a network where we can run a test? What if we only want to use one controller? How are we going to, trigger all those data acquisition instruments and collect the readings? So we'll talk about ways to do all that. Okay, going wireless with LXI. Here is the basic, most easy way to go wireless with LXI. We take a router, just like probably the ones you have at home, Wi-Fi router that has some hardwire LAN connections. It can set up its own Wi-Fi network, and all of a sudden we have a test system and we can connect to it with a controller or a computer. I'll use those terms interchangeably, wirelessly. So now our controller is free to move around, but our instruments are still, of course, wired in one place. Now, as long as the router is not connected to another network, we have, a private local network. You might run into trouble if you actually connect the router to your company's network, because all of a sudden you set up a Wi-Fi access point into your company's network, and the IT department's not going to like that, even if the router is password protected. Another setup or a way to do this is if, once again, you're fortunate enough to work at a company that IT policies allow you to connect instruments to your network. If your network has a Wi-Fi signal, once again, your computer is free to move around. It is wireless, and you can control the instruments. Of course, depending on how the network's configured, you could face added latency. Here, in this model, we can actually free our instruments from the wired location of the router. So here, what are we doing? We're adding Ethernet bridges. And once again, just like a Wi-Fi router, Ethernet bridges are fairly low-cost, off-the-shelf devices. And a bridge is simply going to take one type of data protocol and convert it to another data protocol, communication protocol. Here in this example, it's taking the wired Ethernet of the instrument, converting it into a Wi-Fi signal. And the whole idea is you just configure the bridge to connect to the Wi-Fi router's network. You can do this by, it'll come with instructions and you give it the password, so on and so forth. Now, my instruments are no longer tied to the router, and my controller or my computer is no longer tied to the router. And this is great for, this is the type of setup I have on my bench where I can just move instruments around on the bench and still control them remotely. All I have to worry about is the power cords. Or once again, I'll give you the example of an aircraft or a vehicle where we might be moving instruments around and we don't want to continuously reconnect them to the network or to GPIB or whatever. So once again, that gives us sort of the wireless test system or wireless instrument. Now, I mentioned Ethernet bridges. The truth is today, bridges have been around for a while, and typically when you buy a router or you buy a Wi-Fi access point, these devices are typically multi-function devices because they've become so prevalent and so low cost that typically the device will have multiple capabilities in it, such as a router, a bridge, or a Wi-Fi repeater where it's just rebroadcasting a Wi-Fi signal. Now, another thing that's popped up over the last couple years is what I'm going to refer to as pocket routers, and I'm sort of showing two of them in the slide. And the idea with these pocket routers is they typically have just one LAN wired port, and basically it sets up a router, or it can be an access point or a bridge. And the idea is they're portable, really small, and the best of all is they can be powered, typically they can be powered from a wall connection, AC line, or they can be powered from USB. And so these are typically under $50 US, and you can take them, connect your instrument's LAN connection to them, put them in the bridge mode, and then connect the USB cable to the instrument's USB hub. And the USB is now powering the router or the bridge or the pocket router I'm referring to them as, and the communication is done through the LAN. So now all of a sudden you have a wireless instrument that is no longer, you no longer have to worry about the extra power cord or the added power cord. Now one thing to note, and I should have noted this at the beginning of this section, is with bridges, they can typically be configured to connect to a Wi-Fi network, a standard off-the-shelf router. If, once again, you have a company that allows you to connect your instruments to their network and the company has a Wi-Fi signal, your bridge, more often than not, will not be able to connect to your company's Wi-Fi signal because they add an extra layer of security that does not allow that. Once again, everybody's network's different, and that's something you can talk to your IT department. Okay, so we just got done that section. We talked about sort of setting up local wireless type test setups and some of the trade-offs. So let me get into going the distance with wireless LXI.